this video for any of my band kids that might miss class or anyone else. So we're going to talk through the graphing the trig functions. So what we do in class, and you're going to, if you were here, you would actually take the time. I'm going to give you spaghetti and I'm going to give you this piece of paper. And what you do is you find a partner. One of you would do sine and the other of you would do cosine so that you can see both of them. But if you're doing sine is the y value on the unit circle. So you would come here and you'd measure this with spaghetti, and you'd come here and break off the spaghetti somewhere about here. Sorry. So this is kind of the height of that piece. Pretend I'm close. And you'll notice that this was the height. This is the sine value at pi over 6. So then you would come down here and you would tape this. Excuse me. So sorry. You would tape this in place right here so that it would show you the y value from here became the y value there. And then you would break off one for pi over 4. Sorry, I've never actually done this, but I thought I would try and help you out. So maybe about here. How'd I do? The y value for pi over 4 comes in something like this. So if I tape this here and I tape this here, notice my shape, well, initially, if you think about it, the y value at 0 was 0. So I have 0 spaghetti here, and then it's going up something like this. I'm going to have one at some point that's going to be about here. So I always make you guys do it, and I never do it myself. So it's going to get this high, but what you'll find is that the spaghetti does this sort of thing, and then it comes down and it goes in the, excuse me, you can't see that. So it starts up and does something like this, and then it comes back here and it gets to 2 pi. So this is showing us what sine does. Cosine, however, cosine's the x, so this value, I would turn it and come down here and put it here. And then this one becomes the x value. I'm using the same length. So sorry, you can't see it. That's the length here at pi over 3. This is the length here at pi over 4. So this, try it yourself because it's kind of fun. This is at 0. This one was at, we just said was at pi over 4. And this one was at pi over 3. And then pi over 2, you'll notice, I skipped one of them because whatever. Pi over 2 is 0. So this does something like this, comes back up and goes to here. So if you did all this spaghetti, life would be grand. Now let's move on to this basic idea. That's what the graph looks like. So this, what we had done, you're supposed to in spaghetti do this part and then this part. Here's sine and there's cosine. Okay, so the zeros with sine, well, this first one here is at 0, then this next one is at pi, then this one's at 2 pi, and this one's at 3 pi. So we have infinitely many zeros. So what we're going to say is when x is equal to pi k, where k is an element of the integers. So k can be 0 right here, it can be 1, 2, 3, it could be -1, it could be -2 pi, so those are all the different values. The domain is all real. So from negative infinity to positive infinity, you can take the sine of any angle. The range, however, stays between, it goes as low as -1 and as high as +1. So the range is between -1 and 1. Cosine has the similar idea. For domain and range is exactly the same, but it's zeros here. This one is at pi over 2, and this one, so this one's at pi over 2, this one's at 3 pi over 2. Think unit circle, because this is where this all comes from. You might need to take some time to kind of dig this out yourself, which I'd encourage you to do if you missed it in class. But the x value it's pi over 2 plus pi k, where k is an element of the integers. So then continuing on, here were the reciprocal identities that we've talked about a little bit. Well, these are reciprocal, these are quotient, but okay, whatever. Tangent is the first one here. Tangent is equal to sine over cosine. So when is tangent undefined? Well, it's undefined anytime cosine is equal to 0 because you're not Chuck Norris and you can't divide by 0. So cosine is equal to 0 here. So when x is equal to pi over 2 plus pi k. When is tangent 0? It's 0 when the numerator is 0, which was here. So when is tangent 0? When sine of x equals 0, which is at when x is equal to pi k. So that's what we're going to graph. We're going to sketch that. I'm going to have an asymptote at pi over 2. I'm going to have an asymptote at 3 pi over 2. I'm going to have an asymptote at negative pi over 2. Let me label those. That one was 3 pi over 2. Okay, and I had a 0 here at 0. I have a 0 here at pi. And then if you think about your unit circle, in quadrant 1, tangent is positive, then tangent is negative, then tangent is positive, then tangent is negative. So from 0 to pi over 2, 0 to pi over 2, that's quadrant 1. We need this tangent value to be positive. Well, it's going from 0 to something ridiculously large, but it's undefined here, so it starts approaching that asymptote, doing something like that. Then in quadrant 2, that's 0, or I lied, that's pi over 2 to pi over 2 to pi. These are negative values, and so it's doing something like that, approaching the asymptote that way. Here in quadrant 3, this is pi to 3 pi over 2, pi to 3 pi over 2. It's going something like that. You might need to take some time to chew through this. This is from 0 to negative pi over 2. It's doing something like this. So this is our tangent graph, and it's going to keep doing this forever. So back here, I didn't say this on this one. The period means how long does it take it to do everything it's going to do. So in this one, it had to go up first, it had to go down, and it came back to 0. That's all that it's ever going to do, and it takes it 2 pi to do that. Cosine has a period of 2 pi also. It's just a slightly different. It's the same shape, it's just shifted over, if you can tell that. But its period is also 2 pi. But tangent, it does everything it's going to do from negative pi to pi over 2, negative pi over 2 to pi over 2, which is, or from 0 to pi. So its period is only pi. Its asymptotes where it's undefined, x equals pi over 2 plus pi k. Kes. Oh, that's not Kes. And its domain is everything but the asymptotes. So I would say it's the set x such that x is not equal to my asymptotes. Sorry, my boxes don't work. And the range is all reals. And that's the basic idea with tangent. Okay, cosecant, if you remember, is 1 over sine of x. So when is cosecant undefined? Whenever sine is 0, which was when x is equal to pi k. Whereas cosecant 0, never. I tricked you. Because 1 can't equal 0. So then what happens with this one is that we, I'm going to draw I lied. I'm going to draw sine. Sine looks something like this, roughly. That looks terrible, but you know what I'm trying to do. And we're going to have asymptotes whenever this was 0. So we have an asymptote here, we have an asymptote there, we have an asymptote there. And this is the reciprocal. And remember, we did these in IB earlier this year. And so when sine of x is equal to 1, 1 over sine of x is also equal to 1. So these points here, same thing with negative 1. If this is negative 1, when sine of x, okay, anyway. So these points are in common. And notice as it gets smaller and smaller and smaller, the reciprocal gets bigger and bigger and bigger. And it does the same thing, but in the negative direction. Oh, well, my asymptote. Okay, sorry. Do you know what I'm trying to do? So this one, we joked and called it Lego hands because it's doing this sort of thing over and over and over again. Sorry about that. But it takes it that long. It takes it 2 pi to do everything it's going to do. Its asymptotes are x equals pi k, Kes. Its domain is going to be the set x such that x is not one of the asymptotes. And then the range, it's going to go from negative infinity to negative 1. And then pick it up again and go from 1 to infinity. So this, I like to joke and say, mind the gap, because apparently that's a thing in England that the subways. I don't know, I've never been. So there's that. The next one, secant is 1 over cosine. Secant behaves a lot like cosecant. Okay, so go look that one up. And then cotangent is going to be cosine over sine. So it behaves a lot like tangent, except its asymptotes have shifted. So on this one, they don't have the same asymptotes. Go look at my answer key for this. I just want to make the video not 20 minutes. So On this one, we had asymptotes when sine is 0, which is at 0, and at pi, and at 2 pi. And so it's got zeros at, when is cotangent undefined? At pi k. When is cotangent 0? Well, x equals. This is x is equal to pi over 2 plus pi k. And, but if you think unit circle, when tangent is positive, negative, so is cotangent. So in quadrant 1, from 0 to pi over 2, we need to be positive. So it does something like this. This little interval was quadrant 1. This was quadrant 2, from pi over 2 to pi. I didn't label it, but make sure you're listening. Pi over 2 to pi is negative. So cotangent basically takes tangent and shifts the asymptotes, pi over 2, it doesn't matter which way because there's infinitely many of them, but then it, instead of going from the bottom to the top, it now goes from the top to the bottom. Okay, my answer key is available and should help you finish out the details. Good luck.